All right, example 3 asks us to convert from degrees to radians, and then example 4 is going to go the other direction, radians to degrees. And the fact that you need about degrees and radians is this fact. 180 degrees equals pi radians. And pi is the number pi that is part of the circular formulas that we use for area, perimeter, and so on and so forth for circles. So pi radians, 180 degrees are equivalent values. That's set in stone. So if I'm doing a conversion, it's just basically like any other conversion, feet to inches, miles to feet, whatever. You take your fact about the units that you're converting, use that in order to get rid of one to change to the other. So if I'm converting 43 degrees, I'm going to start with this one, to radian measure. So again, this is marked as degrees, it wants radian measure, so we're changing to radians. I'm going to write 43 DEG. Again, when I'm doing conversions, I prefer abbreviated words as opposed to symbols. So DEG for degrees. I want degrees to disappear and I want radians to appear. So I'm going to put degrees in the denominator for cancellation of units, radians in the numerator because that's what I want to change it to. And the facts about these two units, pi of these equals 180 of those. So pi goes with radians, 180 goes with degrees. Degree on top, degree on bottom. Now it says use the pi button on the calculator, round your final answer to 4 decimal places. So I'm going to multiply 43 times pi divided by 180. Things on top multiply, things on the bottom divide. So 43 times the pi button divided by 180 comes out to that decimal expression. If I want 4 decimal places, I have 0.75049. I'll stop at the 9. This is my 4th decimal place. This is the next digit. Anything 5 or bigger means I go up. Anything 4 or less means I stay the same. So I'm going to go up 1. So 0.7505 radians is approximately equivalent to 43 degrees. Okay, if I do the same task with 60 degrees, the only thing that changes is this is 60 instead of 43, right? It's still 60 degrees. Radians on top, degrees on the bottom, right? So to get the answer here, 60 times pi divided by 180 is going to be the answer. And again, I want 4 decimal places. That's 1.04719. Do not round this up. So you're trying to round to the 4th decimal place, 1, 2, 3, 4. Keep the 5th decimal place, whatever it is, when you go round into the 4th. So I've got 1, 2, 3, 4. There's my 5th decimal place, exactly as it was on the screen. Again, never ever modify the digit after what you're trying to convert or what you're trying to round. All right. So if I see the 1, the 9 means go up 1. So 1.0472 radians is equivalent approximately to 60 degrees. Radians and degrees are 2 ways to measure angles. And your calculator, when you start using your buttons that say sine, cosine, and tangent, the angle you use affects the outcome of those results, of those things. So for example, if I do, right now I'm in degrees, you can see at the top of my screen degrees. If I type in cosine of 60 degrees, it has an answer. If I change my mode to radians, and I type in cosine of 60 degrees, and I'm in radians, notice it's a different answer because I'm not in degrees anymore, now I'm in radians. So again, my calculator doesn't know how to think, it only knows to calculate what I told it to, right? So if I'm trying to calculate cosine of 60 degrees, I want to be in degrees, I get the correct answer. If instead I've got cosine of 1.0472 radians, that should equal about 1/2, not exactly, because again we rounded, but you can see 0.499, that's almost 0.5, right? Because we rounded, it's not exactly the same, but again, my calculator needs to know what mode I'm in, radians or degrees, what type of angle am I working with when I'm using the sine, cosine, or tangent buttons. That's the only time you need to worry about radians and degrees for the use of trigonometry. If I'm hitting sine or cosine or tangent, I need to make sure I'm in the right mode for the way they present the angle in the problem. we would be working with both types of angles in this class.